right, let's take a look here. I want to show you guys something new. We've about polynomials. We're going to look at polynomial division. Now we've looked at how to. I know sounds bad. It's not that bad. We've looked at how to add and subtract polynomials. Piece cake, just combine like terms. Multiplying polynomials, no big deal. Just distribute each term from one polynomial through the other polynomial. Add up like terms, no big deal. Dividing polynomials, as you might expect, is a little bigger deal, but it's not horrible. It's really not. I'm going to go through and show you how to do just general polynomial long division, and then in certain cases, we can do a really nice shortcut that you already know how to do without actually knowing that you know how. So polynomial long division. Here's what you should expect the answers to look like. If we're going to divide some polynomial, and we'll call it p of x, that stands for a polynomial, by some other polynomial, call it d of x for a denominator, how about, then your answer is going to look like some smaller polynomial plus potentially a remainder divided by your original denominator. And this is the same kind of thing you would have seen with normal long division of numbers, right? If we divide two numbers, typically we get a whole number, some integer, maybe that'd be a whole number, some integer plus a fraction, some remainder divided by whatever the number on the bottom was, right? For example, if we divided 11 by 3, we're going to get what? 3 and, which means plus 2/3, right? Same kind of thing is going to happen with polynomials. Same kind of stuff. So let's take an example, and I just want to walk you through just kind of a long example, just of a polynomial being divided. I'll take the one from the book. Okay, so we're going to divide the big polynomial, 2x to the 4th, plus 3x cubed plus 5x minus 1 by x squared minus 2x plus 2. Okay? So when we do that, now, the numerator is the part that's going to go inside the division symbol, right? And then the denominator goes out front when we do long division. So we get something like this then. Okay, now first rule. First rule is that when you put a polynomial inside the division brackets, you got to make sure that you're going to leave a column for each power of x. So if there's a missing term like we had, what do?
Add a 0.
Add a 0. We're going to make that a 0 coefficient, right? So we're going to add in here a plus 0 x squared because we skipped from x cubed down to x. So we need each power of x and the constant gets its own column, just like we did with that synthetic substitution stuff, right? Okay, now the game we play here when we're doing long division like this is we want to ask ourselves, how many times does the leading term of the denominator divide into the leading term of the numerator? There's two ways you can think about that. We could either just divide those out, like so, we could do something like this. We could say 2x to the fourth over x squared equals what? Well, what would that be? 2 divided by 1 is 2, right?
2x.
And then x to the fourth over x squared is x squared, okay. Now, the way I usually do this instead is I usually just ask myself when I'm doing that division, I just say x squared times what is 2x to the fourth? Doesn't that seem easier in a way? Because to me it does. So x squared times 2x squared would give me x to the fourth. And so that's going to be the first part of the polynomial answer. That's the first term. Now, we're going to distribute that. As soon as we get a number up here, we're going to distribute it through each of those, each term in the numerator. Okay? So 2x squared times x squared is 2x to the fourth, right? So forth, and so forth, and so forth. So we're going to get 2x to the fourth. 2x squared times minus 2x is what? Negative 4x cubed. Now we're going to line these up with the right columns too as we go. So minus 4x cubed. 2x squared times 2. Well, that should be squared, shouldn't it? Yeah. Okay, so plus 4x squared. And then we're going to subtract the whole thing. When we do division, it's a process we subtract from step to step. In synthetic substitution, we added from step to step. Here we're going to always subtract, just like we would with normal number long division. Now notice that the first two cancel out, as they should. That's why we picked that number. They need to go away. Now what about the next two? Keeping in mind that we're subtracting. So we get 3x cubed minus negative 4x cubed. So it'd be 7. Good. It'd be 7 x cubed, 0x squared minus 4x squared, negative 4x squared. And then the last two we'll just bring straight down. 5x minus 0 is just 5x, and negative 1 minus 0 is negative 1. So just bring those straight down. Now we just repeat the process. But notice what happened. We whittled this down a little bit. It's no longer a fourth degree polynomial. Now it's a cubic polynomial. Okay? So we would just start over again. Now, x squared times what is 7x cubed? 7x, sure. Okay. So we're going to get plus. Yep. Until we get, until we're done. Yeah, we'll just keep doing this step by step until finally we get this thing whittled down to a point where we can't do it anymore, and then we're done. Okay. So we'll distribute the 7x all the way through. And multiply the 7x by each term, right? And what do we get when we do that? Whoops. 7x times x squared is our 7x cubed. Good. 7x times negative 2x. 7x times 2. Okay, good. And we'll subtract the whole thing. Okay, first two terms cancel, right? What's negative 4x squared minus negative 14x squared? Okay, good. That's like adding 14x squared, so we end up with positive 10x squared. 5x minus 14x, negative 9x, and then I'll bring down the negative 1. Okay, and we got it down to a quadratic now. Okay, so this will be the last step, won't it? How many times, or x squared times what is 10x squared? Okay, and then we'll distribute, right? Okay, so 10 times x squared gives us our 10x squared. 10 times negative 2x. Okay, and 10 times 2. Okay, and we'll subtract. And first two terms cancel. Negative 9x minus negative 20x. Okay, good. I'm adding 20x, so it's positive 11x. Negative 1 minus 20. Okay, and now, does x squared divide into 11x anymore? No.
So that's your
So,
answer.
so that's our, well, actually, the whole thing is our answer. This is our remainder. When the polynomial that we're left with is a smaller order than what's outside in the numerator. So in other words, when the leading term of the numerator no longer divides into what we get, then that's the remainder. Now we knew that was coming though, didn't we? Because as soon as we get a number on top that is a constant, doesn't have any x with it, we know that that's going to be a remainder. It could happen sooner though. Sometimes there won't even be a constant in there. We'll see some examples like that. The rule you just got to remember is when this guy won't divide into this guy, you're done. So this is our remainder down here. I'm going to write that. Well, there's the remainder, right? Okay, so then what's that answer look like? How would we write that answer?
Squared plus 7x plus 10, and then you got the remainder
Mm-hmm.
over the x squared.
Good. So we've got, here's the polynomial part. 2x squared plus 7x plus 10 is the normal polynomial part, plus our remainder divided by what's out front, the denominator, right? So let's write the answer down on the last page. So we grab this, just cut and paste, how about? So there's the first part, right? There's the normal part. And then we got to get this. Here's our remainder. Divided by this guy. Okay, so there it is. Oops. That's our answer. Does that make sense? Okay, this is what our remainder was. That's our original denominator.
So that's your answer?
That's the answer.
Okay, thank you.
That's it. Okay, and they're all like that. Honestly, this is one of the few cases left in your math careers where if you can do one of them, you can do all of them. I mean, they don't change. They're all the same. Yeah.
So when you put in like, so do you have to,
Good question.
yeah, how do you, yeah.
Okay, how would this go into the computer? So if we were going to put this in as a string in Moodle or into a calculator, or when you're in college, if you're putting it into MathCAD or something like that, it would just look like this: 2x squared plus 7x plus 10 plus, I got to put that whole quantity, because there's more than one thing there. If it was just a number, if it was just like negative 21, I could just say minus 21 divided by that whole thing
So
in
you don't have to do
parentheses.
this part of it.
No, I do, because there's more than one thing up there, I have to put that in parentheses also.
I know, but like, so you don't have to plug in the first part that we got, that we included in.
Yeah.
The probability on that, and you have to, you don't have to do the division, you don't have to put that in.
This doesn't have to be in parentheses.
No. Like on the other side of equal signs, like the left side, you have to do that into the answer.
Oh, no, huh? No, that's the original problem.
Okay.
Yeah, this is the problem I would give you. I would say this divided by this equals what?
Okay.
You would do this process, and this whole thing is your answer.
Okay.
Right, so then you just put plus 11x minus 21 divided by the quantity x squared minus 2x plus 21.
Okay.
I think it was just 2.
What's that?
It's 2, not 21. No, it's just part of
Oh, gotcha. Whoops. Okay. There we go. There we go. Okay. Good. All right. So, so that's long division. Now, what that implies then is that I'm gonna do this in a different order. God, this will be good. This will be good. Okay, so shortcut sometimes comes up. What if we want to divide? Oops. Okay, what if we want to do this? What if we want to divide x cubed plus 2x squared minus 6x minus 9 by x minus 2. Okay, now I want you to notice something here. In the cases where the denominator is linear, where it doesn't have an x squared or anything higher than just an x to the 1 in it. Now that wasn't the case in our previous example. In our previous example, we divided by a quadratic polynomial. Okay, so we had to do long division there. But if you're dividing by a linear polynomial, you can do a really good shortcut that makes this process much easier. It's called synthetic division, and here's the good news. You've already done it without knowing it. It's exactly the same process as synthetic substitution. Same exact process. We just interpret the answer a little bit differently. So, so then, let's take this new example, this guy. Okay, now the bottom is linear, right? So all we have to do with synthetic division is we're going to make our synthetic brackets just like we normally would. We're going to take the coefficients of the numerator, go in here. So what would those be?
1, 2, -6.
Good. Okay, everybody getting this?
Yeah.
Okay. Now, here's the one part that's just a little weird. Question? Okay, yeah, that's the part I wanted to talk about. So what's the number that goes out front? What goes out front is the 0 of the denominator. So in other words, if we set this equal to 0 and solve, what is x equal to? 2. X equals 2, so 2 is what goes out front. But we do the same process we normally would with synthetic substitution. Remember, we drop the 1 down, right?
Yeah.
And then 2 times 1 is 2. Say it again. Same thing we did in 6-1. Yeah.
Oh, that's easy.
Now we add 2 plus 2 is 4. 2 times 4 is 8. Negative 6 plus 8 is 2. 2 times 2 is 4. Negative 9 plus 4 is 5. Okay. So here's how we interpret that then. This is our remainder. Okay, now in synthetic substitution, remember what that meant. In synthetic substitution, it meant that if we were to plug 2 into the numerator, in this case, into this polynomial, that was the value of the polynomial at x equals 2. We were just substituting that in for x to find out what the polynomial equaled, right? And it equals 5. Now, that's strange that there'd be this coincidental, well, it's not really coincidental, it turns out, but the value of the polynomial at x equals 2 is the same as the remainder if we divide the polynomial by x minus 2. That's what we call the remainder theorem in Algebra 2, but that's it. It's no big deal. So then what that tells us is that the remainder will be 0 if, when I plug this the 0 of the denominator into the top, I get back 0 for an answer. Now, if I get a remainder of 0, think what that means. That means that I would get no fraction here if I were using numbers, for example. 3 would go into 12 4 times with no remainder, right? Hey, Gabby, why don't you put that away? we get 4 with no remainder. So what we'd say then, right, is that 3 goes into 12 evenly. It goes in 4 times evenly, right? Okay. Is everybody getting this 100%? I mean, because if you were in college, the expectation would be that if you weren't totally paying attention to this, I saw this happen several times in my college career at Stanford. The people would just say, well, you wouldn't expect this to happen a ton, maybe. The professor would just say, get out of here. You know, that's all they'd say. And it was humiliating. The guy'd get up and grab his stuff. And I mean, that's what happens. The expectation is that you're 100% plugged in because that's your only resource. You're not going to get to ask any questions or anything after the lecture. You got to figure it all out. Now, I know that I'm going to take the time to explain this outside of class, but do me the service of at least trying to get it the first time. Looking out there, and some people are really plugged in, and I can just tell that some people aren't. You need to be, okay? All right, so if 3 would go into 12 an even number of times, 3 is a factor of 12. Now, this is important. If you can get this, this makes some harder parts in the chapter really simple. Because 3 doesn't go into 11 evenly, we have a remainder. Now, that same principle applies with polynomials, right? If we had a polynomial that divides into the top polynomial, the numerator, evenly, I would get no remainder, right? Now, just like we would have said that 3 is a factor of 12, because 3 times 4 is 12, if there is no remainder polynomial, doesn't that mean that the polynomial on the bottom is a factor of the top? Right? Okay, so that's really key. That's going to be a big deal to us. Now, in this case, we'll see. Maybe, well, it's not, is it? Because I did get a remainder, that means that x minus 2 is not a factor of that polynomial on the top. In other words, if I were to break that polynomial on the top up into factors, one of them would not be x minus 2.
So that's what that is, the box where it says 5.
Yeah, that's the remainder.
That tells you that there's a remainder.
There's a remainder.
So then when it's 0, then it's not remainder, so then it's a factor.
Exactly. Exactly. Yeah, if you get a 0 in the remainder box, it's a factor. Now, what does our answer mean here? Instead of just us finding out what the value of the function was at 2, this is really a much more important thing. What this is telling us is that the remainder is 5, and these are essentially the coefficients of the polynomial part of the answer. Starting with the constant, this is going to be the coefficient of x. That's going to be the coefficient of x squared. And then it would just keep going. If there were more of them, we would get coefficients of x cubed, and x to the 4th, and keep going. Now, we don't have those in this case, right? We don't have an x to the 4th and an x cubed. So we just stop there. But our answer then just looks like x squared plus 4x plus 2 plus 5 divided by x minus 2, yeah.
Okay.
That's our answer. Okay, yeah, isn't that quick and easy?
So can you can only do that
when it's
the
linear.
X minus 2.
Right, you can only do it when the bottom is linear. If you have an x squared or an x cubed or something down there, you can't. You have to do long division.
Okay.
Right. So let's try one more of those synthetic ones. They're so easy and quick that when you can use them, it's a great idea. Let's do, how about, let's try this. Okay, what about this? Now, think what they're telling us with this information. They're telling us, they're giving us some polynomial, and they're asking us to factor it. Okay, given that f of negative 3 is a 0. So in other words, when x equals negative 3, the value of the function is 0. So negative 3 is a 0 of the function, right? So what does that mean? How does that relate to the synthetic division stuff we just did?
Well, that's what we do.
Right? Now, let me ask you this. If negative 3 is a 0, then what's the factor that goes with that? If I were to set some factor, x plus something equals 0, right? What's the factor that would equal 0 to give me that answer? 3, right? If I set the factor x plus 3 equal to 0, I get the answer x equals negative 3, right? So what that's implying is that original polynomial that we're starting with, when I break it down into pieces, when I break that thing down into pieces, when I factor it, that's telling me one of the factors, isn't it? One of the factors has to be x plus 3, because remember that the whole point of factoring is for us to be able to solve the polynomial equation. When this whole thing is equal to 0, we want to be able to find the zeros, right? That's what factoring does for us. That's why we do it in the first place. So this is one where I would say x plus 3 equals 0, so x equals negative 3 is an answer, right? That's one of my solutions to this. That's a 0 or a solution of the polynomial equation, right? Now they gave that to us in this case, or I gave it to you. We know that this is one of the answers because it makes the original polynomial equal 0. Okay, we want to find the others though. Okay. Well, if we know that's one of them, then doesn't that mean that it divides in evenly with no remainder?
Yes.
Right? Okay, so look, we could set this up as a synthetic division problem. We could take these coefficients, right? Because when we divide this polynomial by x plus 3, we know it goes in evenly. Okay, so 2, 11, 18, and 9. And when I put a negative 3 out front, right, that's our 0, I can guarantee I'm going to get a 0 in that. That's what they're telling us. I'm going to get a 0 in the remainder box. So let's see what we get. If I bring down the 2, negative 3 times 2 is negative 6, plus 11 is 5. Negative 3 times 5 is what? Negative 15, 3, negative 9, and I get 0, sure enough. Okay, but what does this stuff tell me? Yeah, that tells me that this must be the other factor, right? This tells me that when I divide my original polynomial by x plus 3, I get this answer. Now remember what that means. That's my constant, that's the coefficient of x, that's the coefficient of x squared, right? Okay, so then that's got to be what goes here. 2x squared plus 5x plus 3, right? Because, think of it this way. I'm just going to work inside this green box, so that's separate. So what this tells me is if I divide this polynomial, copy it again, copy it again. So that polynomial divided by x plus 3 equals that answer, right? So then, doesn't that mean that if this divided by this equals this, what if I just multiplied both sides by x plus 3? Right? That's going to clear it off the bottom of this side and multiply it by this whole thing over here, isn't it? Isn't it just doing that? Right? I end up with this equals that times that. So look, you see what that did for us then? If they give us a 0, when I run that through synthetically, I'm getting the other stuff that's left over, the other polynomial that's left over, the other factor, right? And that one is quadratic, right? And so if we wanted to find the zeros of this one, we could just set it equal to 0 and use the quadratic formula. Make sense?
Yeah.
Okay. Let's try one more of those, and then that's plenty. That's a lot for today. Okay, so So now look how simple this is. If they give us 1, 0 of this polynomial and ask us to find the others, then we're just going to do this synthetically. We'll put that 2 out front. We'll run it through this polynomial. So the coefficients are 1, -2, -9, and 18. What does the remainder have to be? If it's a 0? No. If this is a 0 of the function, what's the remainder? 0. It goes in evenly, right? So 1 times 2 is 2, plus -2 is 0. 2 times 0 is 0. So -9 and 0 is -9. 2 times -9, -18. Sure enough, I get my 0, right? And then this is what's left over. So that's -9 is my constant, 0x, 1x squared. So I just get x squared minus 9 is the other factor. That's quadratic. So if I set that equal to 0, that's pretty easy to solve. How do I solve for x? Add 9. So x is plus or minus 3. So those are my zeros. I get plus or minus 3 and 2. Okay. That's a lot of stuff. I mean, you got to practice that and ask some questions. Yeah. I wouldn't expect to. No way would I expect everybody to just have that stuff down. You got to sit down and work on the problem set. Go through some hoops, and everybody's gonna have questions. And run into some mistakes here and there, but that's normal. All right, and that's all of 6.5.